I want to address part D of this problem related to inverse functions, particularly related to the inverse functions and their derivatives. So first, let's just talk a little bit about inverse functions. So I have a pretty straightforward function right here, um, y equals 3x plus 2. And you can see that I have 1 point here on that function, 1, 5, and I have another point right here, 2, 8. Those are 2 points on the function. Now, all an inverse function is reversing, switching the x's and the y's. So I can write this, I can just switch the x's and y's right over here, the second line down, and I can say x equals 3y plus 2. That is known, by the way, as the implicit inverse, just switching the x's and y's. And if I do that, then it looks like this. And I have the point, well, let's make this thing back here again, 1, 5. I have the point 5, 1, the inverse of that, and 8, 2, the inverse of that. I could also write that function explicitly by solving for y, and it just looks like y equals x minus 2 over 3. But you can see, I'm kind of clicking on it, you can see it's green to blue and green to blue. It's the exact same function. And that function has those 2 points on it as well. So all an inverse function is doing is switching the x's and the y's. What does that mean then for slope? Well, the slope of my red function here, my original one, I can calculate by, the slope function is the slope formula y2 minus y1 over x2 minus x1. So in this particular case, the slope would be, well, 8 minus 5 divided by 2 minus 1. So the slope is 3, which makes sense because the function was 3x plus 2. Well, on my inverse function, if all I'm doing is switching the x's and the y's, and I'm going to look at this one right here. If I'm just switching the x's and the y's, whoops, let's redo that. If I'm just switching the x's and the y's, then that would be x2 minus x1 over y2 minus y1. Well, that's going to be 2 minus 1 divided by 8 minus 5. It's going to be 1/3, which kind of makes sense because 1/3 and 3 are reciprocals of one another. And so if all I'm doing is switching the y's and the x's, I'm going to have the reciprocal is going to be the slope. So the slope of an inverse function is just the reciprocal of the slope of the original function. And now we get a little bit of calculus here. If I have a function f of x, what's the slope of the tangent of f of x? Well, it's f prime of, come on. Right. Stop. Well, I don't know why, but my little pad stopped working for a minute, so I think I can finish it off here. The slope of f of x is f prime of x. Well, now let's go back to our problem here. The problem is saying let h be the inverse function of f, find h prime of 3. Well, I know from the information that they gave me that f of 0 is equal to 3, which means that h of 0, I'm sorry, h of 3 is equal to 0, switching the x's and the y's. So the slope at h, where h is 3, so h prime of 3 is equal to the reciprocal of the slope of f at 0. Now think about that and make sure you understand it. The slope of f at 0, sorry. That's f prime, f prime at 0. Well, I'm given what f prime is. So that's going to be 1 over, well, cosine of pi times 0 plus 0 to the 4th power plus 6. Well, this right here is just cosine 0. So it's 1 over, well, cosine 0 is 1 plus 0 plus 6. The slope of h prime, the slope of h at 3 is equal to 1 over 7. It's all a matter of remembering that the inverse of a function is simply switching the x's and the y's. That's all it is.